In example number 3 that we're going to work through, we're going to see which group has a larger spread or variance in their data. Now, the spread of the data can also be thought of as how far away from average they are, and that's our variance and standard deviation concepts. I'm going to call your attention to figure 2, and this should relate to something we did last year. Last year we knew that if we calculated the average and the standard deviation, within one standard deviation, 68% of the data should fit within those markings. 95%, or more accurately 95.45% of the data should fit within 2 standard deviations above and below the mean, and 99.7% of the data fits within 3. What we're going to do is we're going to analyze the data that's in example number 3 and figure out which one has the greater spread. We're also going to look at the center as well to see that even though the data could have similar centers of measures, close in mean and close in median, their spread in the data can be quite different. So what we're going to do is we're going to look at this health example. Metabolic rate is the rate at which the body consumes energy, measured in calories per 24 hours. During the study on diet and exercise, the metabolic rates for 2 different groups of men were observed. Which group has a greater variation in metabolic rates? So to speed this up, what we're going to do is we're going to make sure that we can utilize our calculators to take these larger pieces of data to calculate variance, standard deviation, range, and we're also going to look at the mean and median. So what I did is I went ahead and worked ahead. I put in my stat and I edited list 1, and list 1 represents men in group 1 and group 2 is listed in list 2. I'm going to have the calculator go ahead and calculate the univariate measures by doing my stat. We're going to calculate univariate data is one variable stats, so we're going to do the one variable stats on, and I got to tell it a list in which to run this analysis, and after we run the analysis we find the mean is 1603, so 1603.9. The next significant one is S at X, which is our sample standard deviation, and these are going to be samples of the population, so we're not going to use population standard deviation. Typically your sample standard deviation is larger than your population. Then if we cursor down, N stands for we had 20 pieces of data that we put in. The min X is the lowest metabolic rate. Q1 is your first quartile break, which we're going to break it into 4 pieces. The median is right in the middle of your data, so that's your second quartile. Your third quartile is at 1691.5, and then your maximum value is 1764. So we're going to look at 4 pieces of data. The first thing we're going to do is we're going to compare the mean of both groups. So the first one, the mean, the sample mean was 1603 and 9/10. I also want to know the median of this group, and the median they told us through the running of this data, it was 1591.5. I also want to know the sample deviation, so S at X, and S at X was equal to 100.25. So that's indicating some spread. These were measures of central tendency, and the other one that we're going to do is range. And the range is going to be the high minus the low. So the minimum was 1429. Now I need the maximum, 1764. So 1764 minus your minimum, which was 1429. So I got to run that calculation to get the range. So now I'm going to go ahead and calculate that value, 1764 minus our 1429, 335. So it has a range of 335. That's group 1. Now we're going to do the same thing for group 2. Since I already have group 2 listed in and typed in list 2, I'm going to run a stat. So hit my stat. I'm going to calculate another one variable statistics. So I better just stay there. And this time I want to do it on my second list so I can compare it to our first list and run the one variable stats again. So now I'm going to record these. The average metabolic rate for this group was 1,604. The median of this group was 1605. Now I want my sample deviation, which is, slide up a little bit, 54.61. and then I want the range of this group. So I'm going to get the highest and then subtract the lowest. So the highest was 1723, and we're going to subtract the lowest, and the min was 1476. Now I'll run that calculation. 1720. I didn't get the 17, so let me back up here and see if I get typed in. 1723, and we want to subtract from that our 1476, and our range is 247. Okay, so now we're going to make a quick analysis on which of these has a greater cancel. Sorry, just was trying to get that out of the way. Close window for a second. Even though our measures of central tendency are relatively the same, these are awfully close in mean, they're awfully close in median, but if you look at your standard deviation, 100 versus 54, the group that has a greater spread or greater distance from average is group 1, and it also has a larger range between its highest and lowest metabolic rate. So which group has a greater variation in metabolic rates? It's definitely group 1. Group 1 will take the cake because of its range being higher and because of its standard deviation. Now, one final push on this, the standard deviation, if I go back to this, if our average is about 1605, I think it's 1605, when I go out one standard deviation for the first group, I would have to go out about 100. Just to make easy numbers, I'd have to go up to 1705 and down to 1505, and I'd find 68% of the data within there. Where if we did it on our second group has about half of that. So I'm really going to be using easy numbers here. It's about 54.46 or 55. So if I went up 55, that would be up to 1660, and then down 55, it's going to be at, go down 40 would be 1560, so 1565, I believe. This is going to be a much tighter range between our blue ones than our fuchsia ones. So variance, how spread out is your data? And by far, we know that group 1 has a greater variance.